Good morning. I'm Tom Tietz, and I'm the Executive Director of the California-Nevada Cement Association. And I have with me this morning Nate Forrest, our Technical Director. We'll be talking about a subject that's very important to the California cement industry. It's Portland limestone cement. And as you can see in our title, it's coming, but it's not something to be afraid of. Portland limestone cement has been around for a long time. It's got a long proven track record, and it's not new, it's not experimental like other emerging technologies that address CO2 reductions in concrete. This morning, we'll be giving a brief introduction as to who CNCA is. We'll be talking about the impacts of Portland limestone cement and why they're so important, particularly in our state. And then Nate will be talking about specific characteristics of Portland limestone cement. Real briefly, CNCA has been around for nearly 30 years. We're a nonprofit trade association supported by the 7 cement companies in both California and Nevada. And if there's one takeaway that I would ask for when you think about CNCA after this morning, is that we're a great technical resource, whether it's about Portland limestone cement or anything else related to cement and concrete. We're here to be of assistance. Well, here are some big picture items to keep in mind. The greenhouse gas targets that California has envisioned for the next 30 years are significant. And with cement making up about 1.8% of the state's greenhouse gas emissions, have been carefully regulated by the Air Resources Board and will continue to be through this time. And it's important to note that as you look at this graphic, when 2020 hit, we started a new trajectory to get below 40% 1990 levels by 2030. So in the next 9 years, we've got a real challenge ahead of us. And if you look at what's coming as soon as 2045, this is when the entire state is scheduled to be at net zero. We have to be on that trajectory. And Portland limestone cement is the first lever that we can pull to get to that level. Here's a graphic that just begins to show what that impact might look like just for the use of Portland limestone cement in the California market. If it were introduced and gradually adopted over a 10-year period of time, it would have a major impact, up to nearly 10 million tons of greenhouse gas emissions avoided. And as I mentioned right from the start, this is a material that's proven. Here are examples from both Colorado and Utah, where both those DOTs have put down more than 800 lane miles of pavements using Portland limestone cement for more than 10 years. And they're performing very well. And closer to home, here's some projects from University of California, San Diego. As you can see in these images, UCSD is using Portland limestone cement in parking structures, in laboratory buildings, and most recently in their huge project called the North Torrey Pines Living and Learning Center, which opened last August. In that project, we were able to document a savings of more than 3,000 metric tons of CO2 with the use of Portland limestone cement. It's pretty easy to see how that calculation is done in the lower part of the screen on the left, where you see the data from a Cal Portland Environmental Product Declaration that shows a difference of about 10% between a typical 2.5 cement and Portland limestone cement on that project. And lastly, my last slide looks at the big picture and what to expect in from Caltrans in 2021. As I mentioned, Portland limestone cement has been around for a long time. It's growing in use in Canada and in other DOTs around the country. And we've seen it now approved with ASTM, AASHTO, FAA, AIA, ACI, and so forth. Right here close to home in California, we expect a research program. We'll give Caltrans credit for being thorough. They wanted to study this very thoroughly. Their 3.5-year program at Oregon State University is almost finished. We expect their final report to be done by the end of June, and fully expect the Caltrans standards to have Portland limestone cement included in their update in mid-October. So with that, I'll hand it over to Nate, who will dive into more of the technical issues related to this material.
Thank you, Tom. We have an understanding of the need for Portland limestone cement I'll talk a little bit about how it's made and how it performs and how we can calculate the CO2 savings associated with its use. What we have here on the screen is a depiction of a cement kiln apparatus, one of the apparatuses used to make Portland cement. From the left, we feed in raw mix, mostly limestone and clay. And from the right, we have the thermal input, mostly burning coal. The limestone and clay travel down the kiln where they're heated up in what we call a calcining reaction. And out the other end, a product called a clinker comes out. We have two different sources of CO2 emissions that result from this process. The first is from the burning of the coal, typically, to fuel this operation at 2,600 degrees Fahrenheit, and that makes up about 39% of the CO2 emissions. The other source of CO2 emissions is from the ingredients themselves. When we heat limestone to that calcining temperature, the chemical reaction takes place that you see at the bottom of the screen here, turning limestone into lime and carbon dioxide, and that's responsible for about 61% of the CO2 emissions. Now, this process is the same whether we're talking about Portland cement or Portland limestone cement. The difference takes place in the finishing of the material. This is a ball mill, and it's the final step in manufacturing Portland cement or Portland limestone cement. The difference is the amount of limestone that's introduced during this step. Portland cements under ASTM C150 are allowed to contain up to 5% limestone, whereas Portland limestone cements under ASTM C595 are allowed to contain up to 15% limestone. By doing this at the cement plant in the ball mill, we're able to produce a homogeneous material that's closely interground and performs very well. A few different ways that Portland limestone cement works. The first is by improved particle packing and density. We do this in our aggregates for concrete or road base or anything else that uses aggregates to optimize the void structure and maximize the density. And the same thing happens here with our cementitious package in our concrete. It also creates additional nucleation sites from which our chemical reactions in our concrete can emanate. And the third way is through chemical activity. These are somewhat limited, but can produce noticeable strength results when used in the presence of aluminate containing supplementary cementitious materials like slag and fly ash. And now we'll talk a little bit about strength and durability. Now what we have here is strength gain at 1 day, 7 days, and 28 days using both ordinary Portland cement in blue and Portland limestone cement in yellow at 12% limestone. We're also looking at 3 different cementitious packages. On the far left, we have no supplementary cementitious materials. In the middle, we have a 35% slag replacement. And on the right, we have a 20% fly ash replacement. And what you see is that in all cases, at all ages, and in all cementitious packages, the performance of the Portland limestone cement is comparable to that of ordinary Portland cement. Next up, we'll look at some durability aspects, including chloride permeability, ASTM C1202. The 2 graphs that we have here depict permeability at 28 days and 56 days. And like the graph before them, we're looking at Portland limestone cement in yellow and Portland cement in blue. And we have 3 different cementitious packages again. We have no SCMs at both 0.40 and 0.45 water cement ratios. Also have 35% slag and 20% fly ash. And the story continues. The performance of the Portland limestone cement in all cases is comparable to that of ordinary Portland cement. We'll take a quick look here at alkali silica reaction mitigation as well. What we have, a little bit different color scheme because this graph is from a different report. We have an ordinary Portland cement mix in blue, a PLC at 10% limestone in orange, and a PLC at 15% limestone in gray. And what you'll see is that with the aggregate selected for this study, none of those cementitious packages mitigated ASR adequately without a supplementary cementitious material, fly ash in this case. But in the presence of fly ash from 3 different sources, all of those cementitious packages did mitigate ASR. So again, comparable performance. We'll also take a look here at sulfate resistance. What we've got, same color scheme as before, ordinary Portland cement in blue, PLCs in orange and in gray. And we have 3 different fly ashes, A, B, and C, tested at both 15 and at 25% replacement values. And we can see that these concretes were resistant to sulfate at all doses. Again, comparable performance to ordinary Portland cement. Now let's take a look at quantifying the GHG savings. Tom hit on this a little bit earlier, but there's a new website that the Portland Cement Association has put out called greenercement.com. It has lots of information about Portland cement, how it can be used, why it should be used, case studies, etc. But one of the most valuable tools that I found on this website is a calculator wherein you can input the amount of concrete that a project is going to use, and it will tell you roughly what your CO2 savings could be if that project was specified to use PLC instead of ordinary Portland cement. In this case, I've modeled a freeway overlay project that Caltrans is currently bidding that is scheduled to use 465,000 cubic yards of concrete. At 430 pounds of cement per cubic yard to account for the fly ash, the potential CO2 savings on this project are 7,383 metric tons. To help illustrate that point, I took that 7,383 metric tons and put that into this US EPA website that gives you greenhouse gas equivalencies. And we can see that by switching that project to Portland limestone cement, we have the potential to save the CO2 emissions equivalent to 1,600 passenger vehicles, or almost 831,000 gallons of gasoline burned. So these are fantastic savings, and we would encourage you, if you get into a project where you can use Portland limestone cement, to calculate those savings and to celebrate those savings. And we'd love to help you celebrate that. That's about all we have for today, but we'll be here to take your questions. Thank you.